one of the things that we want to do is we want to understand relationships between variables. The reason this is important is because if we're looking for an association or we're looking for a cause and effect, then two variables will have to either move in the same direction or they'll have to move in opposite directions. So the whole purpose of doing analytics is to really provide some prediction or classifications of data, and those classifications and predictions are going to be based on the relationships between the variables. So it's important to have a good foundation for understanding how these relationships are quantified and analyzed. So let's take an example. If we're looking for which customers are more likely to be our high valuable customers, what we're looking to do is identify the relationship between a set of attributes for the customer, such as location, demographic, purchase decisions, etc. And we want to see how those attributes for the customer relate to how much money they have spent within the organization. This way, we'll be able to identify, based on their attributes, the probability that these folks are going to be a high-value customer. Now, there are a number of ways that we will do this. If we have two variables that are both categorical, then we're going to use contingency tables, which are basically counts. If we have both variables are continuous, then we're going to basically use correlation and covariance, which is a mathematical formula that will tell us how strong these relationships are. And if we have a combination of the two, then we may use some summary formats and measures that will kind of give us an indication of what's happening. Now, if we have relationships between categorical variables, remember these are not numeric, but even though we can represent them as numeric, the categorical variables, as we said in a previous module, can be nominal, they can be ordinal, they can be discrete, or they can be binary. So let's take an example if we have male and female students in a class. Well, the most obvious thing is to create a table and do a straight count of the number of male students and the number of female students. Now let's assume that we have two variables, and we have a variable for gender, and then we have a variable for the type of hair color they have. Well, this would be a two-variable contingency table. In this case, because one variable has two options and the other one has three options, it would be a 2x3 contingency table. And it gives us the count of folks that are male with red hair, female with red hair, male with blonde hair, female with blonde hair, and male with brown hair and female with brown hair, brown or black hair. Now in Excel, if we're going to do this, we're going to be using the Countif function. So let's assume that we have some rows and columns for students containing gender and hair color. We'll create the contingency table basically using a number of Countif statements where we'll have the range and a particular criteria. So if we wanted to know the number of students with blonde hair, we would use the following. We would use the Countif function with the entire range, let's say B2 to B50, where the criteria was blonde, and it would give us that total number. Now, if we wanted to know the number of male students, we would do the same thing with a particular criteria, given a range, in this case A2 to A50. Now, if we wanted both students that were male with blonde hair, we would use the Countif function in this manner, where we put the range of data that we're looking at, the criteria that it's going to match, followed by another set of range and criteria that we're trying to match. Once we have the counts of the contingency table, we can add the row sums and column sums to get an idea of the differences between the group. So we'll create our total columns, a total column and a total row. And as you can see here on the right, it gives us the total of red hair, total of blonde hair, total of brown black hair, and the total male and the total female. What's also important is that we might want to create another table which will actually calculate the percents from the grand total, which is the box in green. This will give us an idea of the percentage and probability of having those particular types of students. In this case, we had a 4% male red hair, 4% male, 4% female with red hair, and that would basically constitute the probability of having someone with a female red hair or male with red hair. Now, if we have categorical and numerical variables, then we're looking to examine this relationship, and we have a little bit of a difference that we need to focus on. So here we have an example of the male and female data set that we have. Now, we have a number of scores, the test scores that we have. So from 90, let's say, to 86 for the male, 91 to 89 for the female in rows 1 through 20. So numerically, we're going to obtain summary measures for each of the groups and then do some descriptive analysis. We can also graphically do some charts for comparisons, including box charts and bar charts and box plots. So here's an example of some summary measures that we can create in order to do the comparison. We have our min, max, mean, and median that we saw from a different module, and the corresponding Excel functions of min, max, average, and median. We can also calculate the variance and the standard deviation. Now what's important here is that we can see that the variance for male is 48.45, the variance for female is 24. So we can definitely say that the variance, that the dispersion, isn't so big for the female grades as it is for the male grades. And again, remember that it was easier for us to use the interpretation of the standard deviation. So one standard deviation meant that 68% of the data was within plus or minus one standard deviation of the mean. So in this case, 68% of the data lies within plus or minus 6.96 of the mean, which is 87.15 for males, and 4.97 plus or minus from 91.1 for females. So it begins to tell us the difference in the scores between the male and female students. We can also see the quartile range here, where we have the Q1, Q2, Q3, Q4 given by the corresponding Excel functions. We can then create a box plot to kind of view the differences between male and the female students, and we could see that the chart shows how the male students' scores are generally a little bit lower, and you can see that the variance for the female scores are a little bit, or the dispersion isn't as wide as the male scores. Now, drawing box plots in Excel is a little bit difficult, but it's not impossible, but we have a separate video to show you how to do that.